Hello. In this video, we're going to be talking about how to balance redox reaction using acidic method. All right, so for this redox reaction, if you're asked to balance it, the first thing you do is to find out the oxidation and reduction half reaction. Okay, and to do that, we need the oxidation states of the elements or atoms involved. Now, let's start with aluminium. Oxidation rule states that all elements in their natural state have oxidation state of 0. So this will mean that this has 0 as its oxidation state. All right, let's go to this one. For this compound, what we are looking for will be nitrogen. From the rule, we know that oxygen is -2. So we're going to take nitrogen as X plus -2 times 2 is going to give us -4. And also, based on the rule, this is a polyatomic ion, and the sum of the oxidation states of the individual atoms is going to be equals to the charge of the polyatomic ion. So in this case, I have -1. So X will be equals to -1. When this negative goes to this side, it becomes a positive sign. And -1 plus 4 is going to give us +3. So meaning that my nitrogen here is +3 and the oxygen is -2. Okay, we'll come to this side. The same thing we do. X plus hydrogen has oxidation state of +1. So +1 times 3 is going to give us 3. And this is a neutral compound, which means this is going to be equals to 0. So X here is going to be -3. And which means I have -3 here and I have a +1 on the hydrogen. All right, we'll go to the aluminium. Take aluminium to be S and plus oxygen is -2 times 2, that is -4. And we have a negative charge on the polyatomic ion, which means we have a -1. Then X, -4 goes over to the other side. We're going to have -1 plus 4. The X here is going to be +3. So aluminium here is +3, while oxygen is -2. All right, now looking at this, the individual oxidation states, we can say that aluminium here was oxidized. We have 0 here and we have +3, which means that that compound, that element was oxidized on this other side. So our oxidation half reaction is going to be aluminium to give us AlO2 minus. Okay. All right. Now, which means that reduction, we could see that for the nitrogen, it moved from +3 to -3, which is obviously reduction. So we have NO2 minus to give us NH3 gas. So this is our oxidation reduction half reaction. Now, after figuring out the oxidation reduction half reaction, the next step would be to balance the atoms. So if we look at the oxidation reduction half reaction, we could see that there is oxygen on the right hand side and there is no oxygen on the left. So I'm going to take this to be equation 1, okay? And this to be equation 2. So I have my equation 1. To balance this, I'm going to do aluminium. Now, when balancing oxygen, we make use of H2O, okay? So if we add 2 H2O over here, this 2 here makes this oxygen 2, which means I have 2 oxygen on this side, which balances the one I have on the right-hand side. So I would then have that. Now, the only challenge would be that addition of H2O has also added hydrogen to the left-hand side, which means I have to also add hydrogen to the right. And how many hydrogens will I have? Would be 2 times 2, which is 4. So I have 4H plus. So we add the ion on that side, acidic. That's why it's called acidic method. So this is going to be aqueous. This is aqueous. This is liquid. Okay, now I've balanced the oxidation half reaction. I go to 2, which is my reduction half reaction. I have NO2 on this side. Now on this other side, I do not have oxygen. So what I'm going to do is add 2 molecules of H2O, which is going to be this. And adding this has also made hydrogen to, lag here. So we need to add hydrogen. So we have 3 originally plus 2 times 2, 4. So 3 plus 4 is going to give me 7 hydrogens. Okay, so that's what I will have. Okay, the next step would then be to balance the charges. And to balance the charges, we make use of electrons. Now, the electrons you're adding are negative. So, for example, this first equation, I have 0 here and I have plus 3 here. Now, when adding electrons, you add it to the side with the higher number of oxidation states. So I'm going to be adding my electron on this side of the reaction. And what I need to add is something that when it subtracts from 3, which is my oxidation state of aluminum, is going to give me 0, which is what is on the left-hand side. So the first equation, I'm going to have aluminum plus the 2 H2O, and over here this plus H plus, and then I'm going to add 3 electrons. Okay, now this is plus 3 of this minus 3 of this is going to give me 0 on this side, which means that my charges, oxidation states, are balanced. Now I go over to the 2. I have NO2 plus 7H plus. Now note, I have 3 plus on this side and negative 3 on this side, which means I need to add whatever I'm adding to the left-hand side because that's my higher oxidation state. So I'm going to be adding 6 electrons here. This is because 3 minus 6 is going to give me negative 3, which is what I have on my right over here. Okay, so I have negative 3 over here, which makes sense. So with that, I have my oxidation states balanced on both sides and on both equations. Okay. Okay, so after balancing the charges, the next will be to cancel out the like terms in the opposite directions on each equation. Okay, so here I need to make sure that the charges are the same, and to do that I'm going to multiply equation 1 by 2. So multiply equation 1 by 2. When you do that, this becomes 2. This here becomes 4. This here becomes 2. This over here would be 8. And this one here would be 6. Cool. Now we are done. We're going to go ahead and cancel out the electrons. Hydrogen here is 7. Cancels this, you have 1 left. And then water molecule, you have 2 of them. Cancel this, you have 2 left. At the end of cancellation, we then write out our balanced equation, which is going to be 2 aluminum plus 2 H2O liquid. This is going to be solid plus NO2, and that is going to give me 2 AlO2 and minus 10 plus 1 H plus NH3 gas. So this is the balanced redox reaction. I hope that the explanation has helped you somehow, and hope to see you next time. Take care. Bye.